Today we are going to discuss about the frequency modulating CW radar. Major disadvantage of simple CW radar is it is inability to obtain a measure of range, because here in CW radar we are continuously sending the signal where we don't know when the echo is coming for transmitting signal. So this limitation can be overcome by the modulating the CW carrier. So the frequency modulation technique is introduced. The transmitting frequency we are taking in change of the function with time. The inability of the simple CW radar to measure the range due to the lack of time marking. So the time marking permits the time of transmission and the time of returning be recognized, but it increases the spectrum of the transmitted waveform. This follows from the property of the Fourier transforms. Therefore, a finite spectrum of necessity must be transmitted if transmit time or range is to be measured. So this means if you take more spectrum, automatically it gives accurate measurement of transit time. So the spectrum of CW transmission can be broadened by the application of the modulation, amplitude modulation, either frequency modulation and phase modulation. So what is going to be happen here, by using the CWR radar, we are modifying the CW radar by applying the frequency modulation technique. The greater the transmitting frequency deviation in a given time travel, the more accurate is the measurement of the transit time, but the transmit spectrum also be larger. So now we are going to see amplitude versus time frequency modulation waveform. Here you can see that here you can see the frequency variations. Continuously it is increasing here and here and here, and here we are reducing the time period, again we are increasing the time period, again here increasing the time period. So what it means is, here we are doing the frequency modulation technique, and here we represents the frequency is in that change in time. Frequency is change in time. So here you see how we are going to make the time marking. So here we are transmitting the signal, and here we are receiving the signal. This is the received signal, this is the transmitted signal. So here what I am going to do is, I am producing a time marking of del t time marking. So this is going to be done. So how we are going to find the range and Doppler measurement. So time, here we are taking the time marking is a change in frequency. So the transit time is proportional to the difference in frequency between echo and transmitted signal. In FM radar, the transmitting frequency is change of a function. Assume that the transmitting frequency increase linearly with time. If there is a reflecting object at a distance, or an echo signal will return after a time, that is t is equals to 2r by c, that is the t is equals to 2r. In generally we know that how we are going to get the transmitting signal is, that is 2r, the time is 2r by c, 2r by c. So if the echo signal is heterodyne with a portion of transmitter signal is no linear element, such as a crystal diode, a beat note with product produced, that is FB. If there is no Doppler frequency shift, then the beat note is measured to be the target range. So the FB is equals to FR. Row frequency differences, FR is equals to 0. If the rate of change of carrier frequency is F0, then the beat frequency is FB is equals to FR is equals to F0 into T, F0 dash into T. Here F0 dash into f naught dash into t. So fr is equals to f naught dash into 2r by c. So r is equals to frc into 2 by into f naught dash. Here what do you mean by the f naught is f naught plus deviation frequency. Here what we are going to give, so here we are taking the deviation frequency. F naught dash is equals to f naught dash is equals to f naught plus del f. F naught dash is equals to f naught plus del f. F naught dash is equals to. So now we are seeing clearly that in any practical CW radar, the frequency cannot be continuously changed in one direction only. So periodicity in the modulation is necessary. As it is I am taking here is triangular frequency modulation waveform. So the modulation need not necessarily be triangle. It may be sawtooth, sinusoidal, so some other shape. The resultant frequency has a function of time of the triangular modulation. So the beat note is constant frequency except the turn around region. So here now I am going to find the FR, that is the beat frequency when it is stationary and a stationary object. So if a frequency is modulating at the rate of, because here we are using the frequency modulation, so I have to modulate the signal with certain frequency. So FM is over del F. So the beat frequency is FR. The beat frequency FR. The beat frequency FR is equals to we know that FR is equals to time traveling distance between them and the modulating frequency. So here the modulating frequency is twice the m. This is nothing but the Nyquist rate. So 2r by c. So 2 fm into del f. Fr is equals to 4. If you have conclude and substitution of that, we are going to get Fr is equals to 4 into r into fm into del f by c. So here if you are taking the stationary object, f naught is equals to fr is equals to t into f naught, where f naught is the rate of change of modulation. So here f naught is equals to t into del f by 2 by t tau by 4. So fr is equals to 2t into del f by lf by tau. So 2r by c into 2 del f by 1 by fm. Therefore, you are getting Fr is equals to 4R Fm by del F. R is equals to FRC by 4R Fm by del F. So, you are going to get the range of the target. Now, what I have to require? I have to require to find the range and radial velocity of the target by using the Fmcwradar. So, this is the block diagram. So, this is the block diagram. What is the block diagram? What we are having the consideration. Now, we are going to see. So in block diagram we are having the transmitting section and receiving section. So transmitting section we are having FM transmitter with the corresponding to the FM modulator. So mixer, amplifier, limiter, frequency counter and indicator. So here what is going to be happen is, so here we are having the two frequencies. One is the FR frequencies, other one is the FD frequencies. So this is the frequency and time response. So first figure shows that frequency plot of the transmitted and received signal, and figure B shows the corresponding beat frequency. Now we are going to see how we are going to evaluate the range and velocity. So a portion of transmitted wave. Here first what is going to be happen is, a portion of transmitting signal acts as a reference signal to produce the beat frequency. The beat frequency is amplified and limited to reduce any amplitude fluctuation. This can be done in limiter and amplifier. The frequency of amplitude is limited. Beat note is measured with a cycle count frequency meter calibrating in distance. In the below, the target was assumed to be stationary. If not, a Doppler frequency shift will be superimposed on the FM range beat note and the enormous range measurement results. Here, F0 is the frequency with which the radar transmitter signal is transmitted. In the FM radar, the frequency of time slot of echo signals to be shifted up and down. When target is moving approach, the radar FD will be greater than radar range, that is FR. It increases the portion of FM cycles. The beat frequency FB up will be equal to FR minus FD. So next, when the target moving away to the radar, Doppler frequency will be less than range. Therefore, FD is less than FR. So now, if you want to get the range frequency FR by extracting the measuring average beat frequency, FB up is equals to FR minus FD, FB down is equals to FR plus FD. So we are going to do FB up plus FB down is equals to twice. Here we are getting the radial velocity of the target. So now we have to find range of the target. The range frequency FR may be extracted by the measuring average beat frequency is equals to FB up F minus. First we have to do the sum of the FB up and FB down. We are going to get the range, and if you are when you are doing the FB up minus FB down values are negative, then you are going to get the range of the target. So already we know the range R is equals to C FR by 4 del F into FM. FR is equals to FB, that is beat frequency, FR plus R minus FD, where FD is equals to 2 VR by lambda. So we are going to get the average velocity and average range, average velocity and average range.